Hi everyone, welcome to another episode of Science at Home. So today is the third episode of our live Science at Home holiday special with our holiday kit. So I hope you have got your holiday kit with you. If you haven't, you can buy one. You can get one for yourself from our description down below. You can get the link from the description down below. You can register from the Google form. So today, me, Fatin, your resident social distancing scientist from Penang, I will teach you guys our third experiment, which is acid-base indicator. Acid-base indicator. So, as we know about acid-base indicator, there are three. Every substance, the substance in this world will have three states, which is acid, basic, or alkali, and also neutral. Acid, neutral, and alkali. Mm. Then these substances can have these all these three characteristics: acid, neutral, and alkali. So when we talk about acid, neutral, and alkali, we will also be introduced to pH scale. pH scale, like this one. I will show you pH scale. Yeah, like this one. So this is the pH scale. So in the pH scale, we can see acid, neutral, and alkali. So for acid, the pH value, those numbers on top is actually the value, the pH value. So from 0 to 6, sometimes they didn't include 0, 1 to 6 like that, is acid. And then 7 is neutral, and 8 to 14 is alkali. Then the acid from 1 to 3 is called the strong acid, and then 4 until 6 is called the weak acid. Meanwhile, for alkali, uh, 8 to 10 like that is the weak base, and 11 or 12 to 14 is the strong base, and 7 is the neutral, in which it has none of the acidic properties and also alkali properties. So today, since we are learning about acid and base, I will teach you how to indicate, how to test whether the substance is acidic or basic today. So we are going to do this test today. Mm, So, for properties of acid or characteristic of acid, base, and acid, neutral, and alkali, acid, neutral, and base. So I will now, so alkali now I will mention as base. Okay, so acid and base, acid and base. So the texture of the basic substance. So for characteristic of acid and base, for acid, it can be sometimes corrosive, or it can cause skin irritation. And for basic substances, it has slimy and slippery texture, like the soap at home, the soap that we use to wash hand. That is one of example of basic substances in which it has slimy or slippery texture. So that was for basic substances. For acidic substances, it has the corrosive, as I told you just now, corrosive nature, in which it can corrode or it can irritate your skin. If the acid is quite strong, it can irritate your skin. You can get skin irritation, so you might not want to touch acid. But some acid are safe to touch or to eat, like the lemon juice or orange juice. They are acid as well, but then they are safe to be touched or to be eaten as well. And another acid that we also consume or we also eat is vitamin C. Vitamin C is an example of acid, and sometimes we can obtain vitamin C from eating orange or lemon. All those citrus fruits can have vitamin C in it, and it is very good for our health. Mm. And talking about acidity and corrosive, there is one solution called the Piranha solution. Piranha solution, which is a mixture of a strong acid, sulfuric acid, and also weak acid, which is hydrogen peroxide. So these two, hydrogen, sulfuric acid and also hydrogen peroxide, mixed together, it will produce a Piranha solution. This solution is very acidic, in which it can dissolve anything that falls into the solution, like fabric. Maybe we can, if we drop a piece of cloth into the Piranha solution, the cloth or the fabric will be dissolved easily like that. And it can also dissolve our skin. So if we touch the Piranha solution, our finger might dissolve in it. So you might not want to touch the solution. So that is called Piranha solution. Um, and then so the strong acid will have more corrosive characteristic. Mm. Acid, another characteristic of acid and base that you can use to distinguish between these two is acid has sour taste and basic things will have bitter taste. So like acid like the orange juice, as you know, orange is sour, orange and lemon is sour, so they are acidic. So for basic things like soap is bitter, but you cannot eat soap, okay? I don't eat soap, but they are bitter because they are basic. Uh, so, um, but I don't want you to use your tongue or to eat the things to determine whether the thing is acidic or basic. So today we are going to use to test the acidity or basicity of the substances by using a few materials that we have in our kit today. So the first thing that I want, so now we are going to open our box, our kit, then we will take out the materials that we're going to use today. So we can take the checklist as well. So we are going to use our universal indicator, which is in bottle like this, universal indicator. We will now use our universal indicator. I will show you. Universal indicator. Here we will need the universal indicator. Then the butterfly pea flower. This is the butterfly pea flower. Butterfly pea flower. Then we will need litmus paper. Litmus paper. Litmus paper. And then turmeric paper. This is turmeric paper. We make this from turmeric powder. So it becomes a turmeric paper. We put paper in the turmeric solution. Then baking soda. Baking soda. This is the baking soda that we use in baking. So the name is baking soda, also called as sodium bicarbonate. Sodium bicarbonate. Baking soda. Baking soda. Then sodium carbonate. Just now is sodium bicarbonate. This one is sodium carbonate. Sodium carbonate. Then we need citric acid. Citric acid. Citric acid. Citric acid. Then we need some vinegar that we have provide to you. Vinegar. Then plastic cup, the cups that we have provide to you as well. Some we label them as A, B, C, D, A, B, C, D, the plastic cups, A, B, C, D, plastic cups. And then we will also need some warm water, If you haven't prepared the water, please go to your kitchen, get some warm water with you. And I will suggest you to sit close to your kitchen sink so that it will be easy for you to clean the cups and also the spoon later. We will also need the measuring spoon. The measuring spoon we will also use today. So last week we have used this for slime. Today we're going to use again. Okay, so I recommend you to sit close to the kitchen or somewhere that it is easy for you to clean all the cups and spoon later. Um, if cannot, you can prepare a jar of water like this, a jar of water, and also a basin to contain the water later that we have used. So you can go and prepare your warm water and also the water first. Warm water. Okay, and I also want you to take up the worksheet that we have. This one, the worksheet, acid base indicator. So today we have worksheet special. We have worksheet. So while doing our experiment later, while doing our test later, we will fill up the result in the worksheet here, in the table here. So we have two sides, front side and also at the back here we have the conclusion. We will get to know the result later. Okay, so the first step is, so now we are going to test the first one, which is water. So acid, base, acid, neutral, and base. So this not now we are going to test water. So water should be an acid, a base, or a neutral. So we are going to test the water. So fill up the cup. Fill up two cups, cup A and B. Please take your cup A and B and fill up the two cups with some water. You can put 1 spoon of water. This you can use this spoon, 5 ml spoon. This 5 ml spoon. You can use this spoon, orange spoon or 5 ml spoon. Put 1 spoon of water into the cup. Put 1 spoon of water into the cup. Like this, you get 2 cups like this. Cup A and B, put water inside. Okay. So after you have put the, so while doing this, we will refer to the worksheet, the first part which have the table. We will refer to this one. So according to this here, for water here, number 1, 2, 3, number 3, for water, you will test by using red litmus paper first. Red litmus paper. Red litmus paper first. Water, red litmus paper. So take the red litmus paper, red color litmus paper, and then you dip into cup A. Dip into cup A. Dip into cup A and see the result. Is there any changes to the litmus paper strip? Should be no. The red litmus paper will remain like that. It won't turn any other color. It will turn into other color. So it will remain this color. So there is no changes. You can now fill up the worksheet with the result. So no changes. No changes. So water with red litmus paper, water with red litmus paper, no changes. No changes. No changes. Next, we are going to use the blue litmus paper for the water to test the water. Blue litmus paper to test the water. So take the blue litmus paper and dip into cup A as well. Dip into cup A. Dip and then see whether there are color change or not. Should be no. So that there is no change as well. Like this. No changes. It doesn't turn red, orange or yellow. No. It remains blue. Blue litmus paper. So blue litmus paper will remain blue. Then we will use, so jot down your result. So blue litmus paper with water, no changes. No changes. Water, blue litmus paper, no changes. Then the next one is turmeric paper. Turmeric paper. Turmeric paper, dip into the water. Okay. Dip into the water, the litmus paper. dip into the cup 1, cup A. So no changes as well. No changes. It doesn't turn red, brown, or black. No, it remains yellow or orange like this. So turmeric paper, no changes as well. No changes. You can jot down your result in the worksheet. No changes. Turmeric paper, no changes. Then after that is the butterfly pea flower. So for the butterfly pea flower, first, you use cup E. Take cup E first. For butterfly pea flower, we should prepare the butterfly pea flower solution. Prepare a cup. Take cup E. Take cup E. Put warm water. Put warm water. Put warm water. Put 2 spoons of warm water, which is 10 ml, 10 milliliter of warm water. Put 10 milliliter of warm water into the cup, and then you can put the butterfly pea flower into it. Put the butterfly pea flower, then you can use the lid. Use the lid to cover. Use the lid to cover, and then you can shake the container. Use the lid to cover, and then you can shake the container. Use the lid to cover, then shake the container to mix the butterfly pea flower and the water. So we will get the butterfly pea flower solution. That is, it will turn a purple blue like that. So after you mix for sometimes, after you shake for sometimes, it will turn purple like this. Very nice color. So butterfly pea flower is sometimes used in food as well. You can make the kueh, and also sometimes people use it to make rice, nasi kerabu. The purple color rice is actually comes from this flower, and sometimes they use artificial coloring as well. But usually, originally, they use the butterfly pea flower solution to make the purple rice or blue rice. So it will turn like this. So now we are going to use this butterfly pea flower, butterfly pea flower solution into the water. So drop or pour a little bit into it, and see whether the color change into green, pink, or red. No, right? So when you pour the butterfly pea flower solution into the water, it will remain. Pour into the cup A. Pour into cup A. So it will remain as purple or blue color like this. It will remain, no change at all. No change at all. It will remain like this. So butterfly pea flower and water, no changes as well. No changes. So for the last one, we are going to use the universal indicator. Universal indicator. Where is the universal indicator? In the bottle. So it is here. This is the universal indicator. Universal indicator. So now we will use cup B to test. So open the cap, then drop a few drops, maybe 2 or 3 drops of the universal indicator. I would suggest just 2 drops into the water, into cup B. 1, 2. And you will see no changes as well. No changes. The water will remain like that. Okay. But actually, if you put more, the water will change into green color. Just now we dropped 2 color only. We drop 2 drops only. So you cannot see the difference. You cannot see the color change. But if you drop more, you can see that it turns green. It turns green. So what does it mean by green? Just now we put 2 drops, but then if you add more, like 5 drops maybe, 5 drops of universal indicator into the water, it will turn green like this. See? Just now the water is clear, but when you add more universal indicator, it turns green. It turns green. So what does it mean by that? So back to our chart, back to our pH scale just now. Green color means neutral. It should be neutral because water is neutral. Water don't have sour taste. Water is not bitter as well. Water is just bland taste. Water just not, it's not acidic or it's not basic. So water is neutral. That's why it turns green. So the universal indicator will indicate that when you drop the universal indicator into the water, it will indicate that it is neutral based on the color, which is green color. So water is neutral. So you can jot down in your worksheet that here universal indicator and water, it will become green. You can write here, it turns green. Green, GRREN. So can, it turns green. It turns green. Okay, so now we are done with the first one, which is water. Now, I would suggest you to wash your cup A and B, go wash. Just rinse them and make sure that you clean them well because we don't want the solution to mix with other solution later, then you will not get the result that we want. And because you might spoil the solution if you already has the basic one, then you add, you didn't clean, you just add the acidic, you might not get the result that you want. So clean them well, rinse them well, and then dry the cup a bit, dry the cup using cloth or tissue. Then now we are going to use cup A, B again, and also C, D. Prepare your cup A, B, C, D. If you need to wash your A and B, you can go wash now. Cup A and B and C, D. Cup A, B, C, D. Cup A, B, C, D. Then, I hope you are ready with the cup A, B, C, and D. Then, for the first cup A and cup B, you add 1 spoon of warm water. 1 spoon of warm water like this. 1 spoon of warm water. 1 spoon of warm water. 5 ml, 5 milliliter. 1 spoon into the cup. Okay, 1 spoon into the cup. Then do for another cup, cup A and B. Do for both cup A and cup B. Do for another cup as well. Cup A and cup B, put 15 ml. 15 ml, not 5. 15 ml. This one is 7.5. This one is 15. 15 ml. So put 15 ml of the water, warm water, into the cup. 15. I couldn't see clearly, so it's 15, okay? 15 ml. So put 1 spoon into cup A and another spoon into cup B. 1 spoon cup A, 1 spoon cup B. So you get 2 like this. Cup A and B, 1 spoon, 1 spoon. Okay, after you have done pouring the water into cup A and cup B, both, then take the citric acid. Citric acid. Citric acid. Okay, take this pack of white powder, written there citric acid. Okay, citric acid. Then pour half into one cup A and pour another half into cup B. Half into cup A and half into cup B. Then you can use the small spoon to stir them, to mix them. Mix them well. After you put the powder into cup A and cup B, then you can mix them. Mix them well until you cannot see the powder anymore. Until you cannot see the powder anymore. Mix, 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 mix. So So you get 2 cups like this of citric acid solution. So solute and solvent, solute also called or the citric acid powder is the solute. Then mix into solvent, which is the water here is the solvent. When the two is mixed together, they become solution like this. Solute, solvent, they become solution. So we have now citric acid solution because we put citric acid powder just now. So we use warm water is to make it easy for us to mix this thing. So it is easier for the citric acid powder to dissolve in the water. And that's why we use warm water. If we use cold water, we might need to stir more, mix more. So now we have these two citric acid solution, cup A and B. So now we will use cup A first. Now we will do cup A first. So like what we have done just now, we will test with red litmus paper first. So see here, citric acid, then we will test with red litmus paper first. Citric acid with red litmus paper first. Then we will see the result. Red litmus paper into cup A of citric acid. Then dip into it. Okay, and see the result. Citric acid, and then red litmus paper. Is there any changes? No, there is no changes. So no change. You can write in your worksheet. Citric acid, red litmus paper, no change. No changes. Nothing changed. It doesn't turn the red litmus paper into other color. So it remains. Then after that, blue litmus paper. Blue litmus paper into the citric acid solution. So dip the blue litmus paper into cup A. Dip the blue litmus paper into cup A. You might now see the result. Okay, so the blue litmus paper turn red. Blue litmus paper turn red color. The blue litmus paper will turn red. You can jot down in your worksheet the result, blue into red. Blue to red. You can write red. So citric acid with blue litmus paper, it will turn red. Okay, turn red. After that, we will use the turmeric paper. Turmeric paper, turmeric paper, turmeric paper. Then dip into the cup A. Dip into cup A. Turmeric paper, dip into cup A. Is there any changes? No, no changes. Turmeric paper into cup A. No changes. So you can jot down the result, no changes. Turmeric paper, citric acid, no changes. No changes. Then next, the butterfly pea flower. The butterfly pea flower. Now into cup A, we are going to pour some butterfly pea flower solution. Put some. Then see the result. Oh, we have nice result here. Maybe I will add some more, a bit more. Don't pour all, later we will still use. So it turns purple or pink like this. Purple or pink. See? So butterfly pea flower added into the citric acid. Butterfly pea flower added into the citric acid, it will turn pink or purple. You can say pink. I think pink. Based on what you can see from your result, it is purple or pink like this. Purplish pink. Pinkish purple. Like this. Then done for cup A. Now we will do for cup B. So cup B, we will use the universal indicator. Universal indicator. So for cup B, we will use the universal indicator. So you can drop a few drops into the cup B. See what happened. Maybe you can add 5 drops like that. Yeah. So you can see that the solution turn red or orange like that, reddish orange like this. Yeah, orange. I believe the lighting here will make it looks orange like that. Orange. Yeah, yellow, orange, or red like this. Okay. So we are done with the citric acid solution. So based on the pH scale or the pH scale, the the one that we turn those substance or solution that we turn red or pink like this is those in the acidic range. Those in the acidic range. So it will turn red, pink, orange like that. So they are acidic. So yeah, citric acid, as the name is acid already, so it is acidic. Citric acid is acidic. Then we will do for the next one. So now we will use cup C and D. 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 Okay, get ready with your cup C and D. And now into cup C and D, we will pour some vinegar. Vinegar into cup C and D. Vinegar into cup C and D. Like this. Don't pour all of the vinegar. Just make sure that there are enough in the 2 cups. Then left some here because we're gonna test a bit later. 2 cups like this. Vinegar. Put the vinegar into cup C and D. Okay. I believe you have done pouring the vinegar into the 2 cups. Then, as usual, we gonna test using the first one, red litmus paper. Red litmus paper. Red litmus paper into the solution. So, no changes as well. So the red litmus paper remain red litmus paper, no changes. You can jot down your result. Red litmus paper and vinegar here, no changes. No changes. Then we can continue with the blue litmus paper. Blue litmus paper into cup C vinegar, into cup C of vinegar. Oh, it turns red as well. So the blue litmus paper into vinegar, it turns red. Blue litmus paper into vinegar, it turns red. And right, red. Then the next one is the turmeric paper. Turmeric paper into the cup A, into cup C, turmeric paper into cup C of vinegar, dip. No changes as well. No changes. No changes. Then the next one is, so you can jot down turmeric paper into vinegar, no changes. So the next one, butterfly pea flower into the cup C, vinegar, cup C. Butterfly pea flower into cup C vinegar. Pour some. Yeah, so it will turn purple or pink as well, just like the citric acid. It will turn purple or pink like this. Pink, pink, pink. It will turn pink. So you can jot down the result. It will turn pink. Okay, pink, pink. Not purple, it's pink. Pink, like this. Okay, so pink, butterfly pea flower turn pink into vinegar. So done with cup C. Done with cup C. Put aside first. Then we will use cup D. Cup D. Cup D of vinegar. Now we will add the universal indicator into cup D. Universal indicator into cup D. See what happened. Add 5 drops like that. Maybe more. Okay, like 8 drops. So you will now be able to see it turns orange or red like this, reddish orange. Same like when we drop universal indicator into citric acid. So it turns orange red. So you can jot down the result, orange red. Now you will be able to notice from the result that you have for citric acid and vinegar, you will be able to notice that the result is almost the same. The color change is almost the same because they are both actually acid. That's why they change into same color because they have same properties, same characteristic. They are both acidic solution, acidic substance. Okay, so now we are done for citric acid and also vinegar. Now we will continue with the next one. I think you can go wash the cup A, B, C, and D first. You can rinse the cup, then come back. You can dry the cup first. Rinse the cup and dry the cup first using tissue. So examples of acidic substances of acidic things are just like what I've mentioned just now. Citrus fruit like orange, lemon, they are acidic and they are edible. Edible means it can be eaten. It is safe to eat, like orange and lemon. And vinegar, yeah, like we have done just now. Vinegar is one of the acidic substance as well. As you, if you smell the vinegar, if you take a sip of the vinegar, you can tell that it is sour. It has the sour taste for vinegar. And some acid like the citric acid and also citric acid and also vinegar. It is also actually used in making cheese. Cheese. So cheese is made from milk, as we know. Cheese is made from milk, but to make cheese, to make milk, to turn milk into cheese, we will need an agent or the vinegar or also the citric acid to make the to make the milk plump together, so it will become a curd, like a curd like that. It will become plump, or it will solidify a bit. Then this clump is then extracted and become the cheese. We will remove the remaining solution and we will take the clump milk to be the cheese. So that's how cheese are made. There are many other ways, but one of the main ingredient in making cheese is milk and also some acid, citric acid or also vinegar. Can also use lemon juice. Okay, then I hope you have done cleaning your cups. Now we will use cup A and B. We will use cup A and B. And as usual, put a spoon of water, 15 ml, 15 ml of water of warm water into the cup. Put 15 ml of warm water into the first cup, into cup A, B, warm water into cup A and B. Put warm water into cup A and B. After you have done with the warm water, you can now add the baking soda. Add the baking soda or sodium bicarbonate. Baking soda. Add half into cup B, half into cup A, half into cup A, and half into cup B. Baking soda into cup A and cup B. Half baking soda powder into cup A and cup B. Then use the spoon. Make sure you clean the spoon first because just now we make citric acid, which is acidic, and now we are missing baking soda, another substance. So make sure you clean first to avoid contamination and mixing. You can wash them first, then only you use to rinse your to mix your baking soda solution. Put the powder and then mix them together. Mix them. So you will then get baking soda solution or sodium bicarbonate solution. That is 2 cups. Both do for both cup A and B. Okay, I hope you have done with your baking soda solution. Then, as usual, you will then test with red litmus paper first. So red litmus paper into baking soda solution. Red litmus paper into baking soda solution. Red litmus paper into cup A baking soda. You can see a slight change of the color. So the red litmus paper should actually turn blue. So it is actually opposite to the previous one in which blue, there is no change, but red got turned blue. But this one, red turned blue. Red turned blue, and we will see then after this, we will see what red turned into. So now red turned into blue. You can jot down the result. Red litmus paper into baking soda, it turns blue. It turns blue. Red litmus paper into baking soda, it turns blue. After that, test the blue litmus paper. Blue litmus paper into cup A baking soda. Blue litmus paper into cup A baking soda. See whether there are changes or not. There is changes or not. Oh no, no changes. So yeah, so it's correct. It is basically memang totally opposite to the previous one in which for vinegar and also citric acid the the blue turned red. Now the red turned blue. Yeah, for this one blue no changes. Blue into baking soda no changes. Blue litmus paper into baking soda no changes. Then we will test the turmeric paper. Turmeric paper into cup A. Turmeric paper dip into cup A. Dip, 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 dip. Okay, now you can see the changes. Just now it is for basic solution. It just like this, same color, same color. This is for vinegar and also citric acid. Just now it remained this color, but for this solution baking soda it turns red or orange brown like this. Red orange brown like this. I would say red. Okay, you can jot down the result. Jot down the result. Yeah, becomes red. So the turmeric paper turns red. After that, so next we will do for butterfly pea flower. Butterfly pea flower. So the butterfly pea flower into cup A. Butterfly pea flower into cup A. Pour a bit and see the result. See, mix, mix, mix a bit. Swirl the cup. So it should actually turn green or blue like this. Blue. I would say blue. I saw blue here. Yeah, I believe you can see blue as well. So when we put the butterfly pea flower into cup A with baking soda, it turns blue. It turns blue. You can jot down the result. It turns blue. Okay, cup into cup A. So cup A is now done. Turns blue. Now we will test for cup B. So for cup B, we will drop the universal indicator. Cup B, we will drop universal indicator. Drop. So you can see obviously it changed into blue color. Blue color. Let me show you. Blue color. So universal indicator into baking soda solution, it turns blue. It turns blue. Blue color. Can jot down the result. So back to our scale just now. So when a substance turns into blue color, it means that it is alkali or basic. Alkali or basic. So means that the baking soda solution is actually a base. it is base or alkali. Then now we should continue with our next one, the next solution. So now, as usual, take 2 cups. 2 cups. Now we will use cup C and D, cup C and D, cup C and D. So into the cup C and D, put 15 ml of warm water. Cup C and D, put 15 ml of warm water. Okay. Then when you get the 2 cups of warm water, cup in cup C and D, then you add the sodium carbonate powder, sodium carbonate powder into both cup. Put half, half, put half, half, half into cup C and half into cup D, half into cup C and half into cup D. Then use the spoon. Use the spoon. You can also rinse the spoon just to be sure. Rinse the spoon and then you can mix them together. Mix them together until you cannot see any sodium carbonate powder anymore. Mix them well. Mix them well. Mix them well until you get the 2 cups of the 2 cups of the sodium carbonate solution. Sodium carbonate solution. Okay, then as usual, we will test using the red litmus paper. Red litmus paper. So red litmus paper into cup C of sodium carbonate. Cup C of sodium carbonate. Oh, so the result is blue as well. So red litmus paper turns blue. Red litmus paper turns blue in sodium carbonate solution. Then, as usual, we will test with blue litmus paper. So blue litmus paper into cup C of sodium carbonate. Oh, it seems no changes as well. No changes. So blue litmus paper, no change. Blue, no change. Okay, then for turmeric paper into cup C. Turmeric paper into cup C of sodium carbonate. It turns red, very clearly red. It is red color. It turns red color. So jot down in your worksheet. It turns red. After that, we will test by using our butterfly pea flower. Okay, so into cup C, pour some butterfly pea flower solution. Oh, so it turns bluish green like this. Bluish green. It can also be tell as purple like this. So sodium carbonate mixed with butterfly pea flower, it turns blue green like this. Blue green. You can jot down blue or green. I would say blue. Then after that, for cup D, we will drop some universal indicator. Cup D, drop some universal indicator into it. Oh, so it turns purple. This one is obviously purple. It turns purple. So from clear water just now, clear sodium carbonate solution, added with universal indicator, it turns purple. It turns purple. So back to our, you can jot down the result. It turns purple. Back to our pH, pH, pH scale. Back to our pH scale. Okay, back to our pH scale. For solution that turns purple or blue, it is actually base. So you can take your cup A and B with baking soda solution. They also becomes blue like this. So both become bluish purple. Means that baking soda or sodium bicarbonate and also sodium carbonate, they are both actually basic. They are basic solution. They are alkaline. They are alkaline. both blue and purple. So they are all basic. Okay, so then um, so that is how we determine the acidity or basic of a substance. Universal indicator is actually used to determine. It can actually used to determine until the number of the pH value, not only whether it is acidic or basic. Like the litmus paper or also the turmeric paper, they can only determine until whether it's base or alkali. It can be it is base or acid. It is acid or base. Just to determine until that. But for universal indicator, it can determine until the pH value. Like the last one just now, the what is this? Sodium carbonate. When it is added with universal indicator, we get purple color. So it means that the pH value can be maybe in between 12 to 14, 12 to 14 like the pH value, because universal indicator is used to determine until the pH value. So when we mix acid and base, we can actually get a neutral solution. A neutral solution. You can actually get a neutral solution. So now this is some warm water. This is just to show you to test this. To test this. Inside is actually some warm water and also mixed with sodium carbonate. So this is a basic solution. A basic solution. Sodium carbonate and also warm water. So this is sodium carbonate solution, a basic solution. When I add vinegar, which is an acidic solution, so acid and base, acid mixed together, you should actually get a neutral solution. But now maybe you don't believe me that it is basic. This is kind like magic. So if you want to know whether it's magic or it's basic or acidic, we will use the universal indicator. This is very useful. So we will drop the universal indicator to determine whether this is an acidic or basic solution. Yeah, so it turns pink. It turns pink. Purple color. It turns pink. So it is basic. It is basic. So this is sodium carbonate solution. Then when I add vinegar into this, this should neutralize the basic solution. So when we say neutral, means that it doesn't have the basic or acidic properties. So we will add the vinegar into the basic solution. Oh, got some bubbles, a bit bubbles. You can mix them, and they turn clear color on, or they will turn clear. They will turn into clear color. Then yes. So I have add some acid into it. So it turns green because it is neutral. So it should turn green because it is neutral now. So just now is basic sodium carbonate solution added with vinegar, and it undergo the process called neutralization. So this solution should be neutral. So when I add the universal indicator, this should turn green. This should turn green. So I will add this into the solution. Okay. So now, oh, it turns green. Not so clear, green. So I will add more universal indicator. Now it turns green. So this solution is neutral because it undergo the process called neutralization. So basic added with acidic solution, it becomes neutral. This is green. You might see it as blue, but it's actually green. So our body has a solution, an acidic solution as well. Inside our body, there are acidic and basic things, substance as well. So inside our body, especially in our stomach, is called the gastric acid. Gastric acid or the stomach acid, or also called as gastric juice. Gastric juice, in which the gastric juice, which is located in our stomach, the stomach acid, it has a very strong acid, which is the hydrochloric acid, HCl. The chemical name is HCl, hydrochloric acid. So the common name is stomach acid or gastric juice. The scientific name is hydrochloric acid. So hydrochloric acid is a very strong acid. So this acid is used in our stomach to digest our food. So when we eat something, the acid inside our stomach will then digest or dissolve the food that we eat. Then we will not get indigestion and whatnot. And then the acid, but then why we still have we still alive even though we have a very acidic acid in our stomach? So the some of the cell in our body will then release a basic solution to neutralize that acid. So that's why we don't get we didn't die because of that acid. So that is one of the function of neutralization. Then so from our worksheet, the second part here, as you can see, the question says, what can you say about the materials? Which one is acid, base, and neutral? So you can fill up the table with your answer. As we have tested just now, what is acid and what is alkali, and also what is neutral. So as I mentioned just now, the neutral solution that we have used, which has no change in anything, but in universal indicator got lah, is the water. Water is neutral. So water is neutral, having pH value of 7. So water is neutral. So just now, water turns green because for the universal indicator by the pH scale, it is neutral. Water is neutral, no taste. Okay, so water is neutral, 7 pH value. So then, what is acidic? What are the things that is acidic? So from our first test, after water just now, we actually test for acid, which is the citric acid and also vinegar. Citric acid and vinegar. I have the example with me, citric acid and vinegar. So this one is for citric acid. It turns red or orange like this, means that it is acid. So you can see that in the scale that acid can turn into orange and red like this. So this is acid. So citric acid is acid, as the name citric acid. And then for vinegar, vinegar turns into red, pink, and also orange like this. Red, pink, and orange. So it is also acid. It is also acid. Vinegar is also called acetic acid. Then, so acid is citric acid and also vinegar. Then the next one is basic. Which one is base? Which has a pH value greater than 7. So this baking soda, and also baking soda turns blue, green, and sodium carbonate turns purple, blue like this. So these two are also basic. Baking soda and sodium carbonate is basic. They are base solution. So for the conclusion at the back here, this is just the summary of what we have done here. So from what you have filled up in your table, you can conclude here. So for blue litmus paper, it will turn into what color? So blue litmus paper will turn red when it is mixed with acidic solution. Blue litmus paper will turn red when it is mixed with acidic solution. Then the red litmus paper will turn blue. The red litmus paper will turn blue when it is basic, when it is mixed with basic solution. So the The litmus paper remain unchanged when it react with a neutral substance like the water just now, so no change, not become blue, not become red, so they are neutral. Then the turmeric paper will change red. The turmeric paper will change red when it is mixed with basic solution, basic substances. It turns red. Then the butterfly pea flower, they become red when they react with acidic substances. Yeah, the butterfly pea flower solution will turn red when it is reacted with acidic substances. Then for the last one, number 4, the conclusion for universal indicator, it turns more red when it is acidic because uh, the the red color is strong acid. Uh, so it turns more red when it is acidic, and it turns more blue. It turns more blue when it is mixed with something that is basic. So universal indicator turns red when it is acidic and more blue when it is basic. So that's for our acid and base indicator today. In chemistry, the acidic solution, acidic substances is said to contain, to have more H plus ion, hydrogen ion. It has more H plus ion, hydrogen ion. And while for a basic solution, it has OH, hydroxide ion, hydroxide OH minus ion. So the more the H plus, the more the hydrogen ion, the more acidic the solution. And the more OH, the more hydroxide solution ion, the more basic the solution is. Then, yeah, so I hope you have learned something from this video. So mixing things is quite interesting. It's like a magic. You can turn color. You can turn a clear water into green color. You can turn some red paper into blue paper. So acid and base is very interesting. I hope you have learned something from this video. Don't forget to like, share, and subscribe to this video, to our channel. If you haven't bought the kit, you can get from the link in the description down below, and you can register and get your kit, and we will send the kit right to your house. And don't forget, if you still haven't got your kit, you can buy now, because we have one more live session next week with our experiment, which is solar oven. It is very interesting. Don't forget to catch that up. And then, yeah, I hope you have learned something from this episode. Thank you for watching this video. Don't forget to subscribe to our channel and click the bell icon. See you next time. Bye bye.